And we'll have welcome our special speaker for today, David Gomez Garcia. He's a developer advocate at Axon IQ. He's also a Java champion from the class of January 2020. He has a computer science degree from the Polytechnic University of Madrid, and he has deep experience in software development for over 20 years in all kinds of vertical industry: banking, defense services, retail, maritime, ground transport, everything. And he's a certified Spring Source instructor from 2010 to 2015. Then he's also a certified advanced Java specialist courses instructor, right, in Spain since 2011. He's also a very active tech community builder and organizer of Madrid JUG. And that's where actually myself and David met too. And David has such a great time and such a gracious host. And I still have fond memories of Madrid. So anybody wants to visit Madrid, please visit and tell David about it. Yeah, he will really be a great host. Okay, and one more thing is he's also the organizer for the Lambda World Conference in South Spain, right? Cadiz, Spain. So with that, I pass the baton to you, and welcome again, and thank you, David.
Okay, so I would like to start this session by sharing something personal with you, something personal around about the reasons that I have for thinking in the topic of this session some time ago. And it was just because at some point, some time ago, I was seeing some friends going through some suffering, going through some pains, because in the projects that they were working for, they were forced to have some kind of they were forced to follow some guidelines or to apply some ways to split their project or to organize the teams, just because they were trying to enforce some specific architecture. In this case, it was microservices. But then I realized that at some point we all were suffering from similar pains or from similar problems. And this was because we were trying to deal with a lot of complexity at a very early stage in some of these projects. Well, it seems that this is not so personal, because recently, a couple of weeks ago, I read this blog post at InfoWars about the complexity and how it's killing software developers. And the author here was trying to express that nowadays, software development is much more complex, just because we are trying to deal with an environment in which we are forced to keep in mind some features or some requirements, like having to be elastic or being able to scale in dynamically, and being able to support workloads that could grow or decrease at any moment. And we need to do that in an efficient way. And trying to deal with that extra layer of complexity at a very early stage in the way of the projects could indeed suppose a problem for us. So the first title that I have for this talk was this one, "Don't let the microservices hype ruin your project." But then I realized that this wasn't a good title, because maybe you will think that this is going to be a rant on microservices. And I kept this slide just because I want to state this up front. I don't have any problem with microservices. This is not going to be a complaint about microservices. This session is probably going to be a reflection. This is an effort to try to make us think on the hype thing, or the hype part of this microservices hype, and how any kind of hype indeed can win your project if we try to apply that at the very early stage in our projects. So my proposal here, what I want to do is I want you to go with me in a particular project. Let's try to play a role playing in which we are going to start a new project. Let's say that next Monday, when you arrive to the office or when you open your laptop at home, your manager says to you that you are going to join a new project that starts from scratch, and you have to design everything from a blank sheet of paper. Or maybe it's not a new project, but you are assigned to redo or to create a new module or a new feature for the project that you are in. But this time you will probably have this idea of this time we are going to do the things in a better way because we are going to get it right. And of course, getting the things right means that we need to deal with this requirement that we will at some point have to support a very high workload because we are going to be extremely successful in our project. And also, we probably will need to be prepared to support some elasticity or to deploy on the clouds in an independent manner different parts of our application in order to support that workload in an efficient manner. So the next thing that we are going to do when we are assigned with these kind of requirements is probably we are going to open our browser, we are going to go to Google, and we are going to start searching how others solve these kind of problems. And probably the more that we look, the more that we search, the more that a particular word starts popping up in our search result. And that word is basically the microservices architecture. So we start digging into that, and we soon learn that microservices architecture means that we need to split our project in several different independent modules. And maybe those modules could be developed by different teams that could even decide to choose different languages, or they could choose to deploy at different times. And they will be completely dependent, and our project will be composed of all these microservices. But at this point, you realize that these microservices, these modules, are part of a bigger solution, are part of the whole project. And then they need to they depend on each other, because at some point, one module is going to require some information from other module. And then we will probably start thinking in how we are going to coordinate these calls, whether we are going to design on REST API, or if we are going to use gRPC calls, or if we are going to have some kind of contracts. But also at the same time, we will realize that if we are going to rely on features that are provided from other modules, we also have to keep that in mind, because if we are going to deploy, we need to make sure that other modules have also deployed before with the features that we need. So at some point, we will realize that we need to draw the chain of dependencies between all these modules. And at some point, we will need to coordinate how we are going to develop or deploy all these microservices, because they are dependent, they depend on others. So at some point, we will find ourselves in the situation that my 2-year-old son found himself a couple of years ago. And he was trying to find on a stream of paper, in a stream of paper, where the stream was starting and where was the end. And probably that will be the same situation that we can find ourselves in, because at some point we will draw this chain of dependencies, and we will find that these chains of dependencies are circular, or they have no end, no beginning, and we will have all this mess around our neck without not knowing how to deal with that. So that's part of the problems that we could face. There are many other problems that we could face if we don't apply this architecture in a good way. But which was the problem in this case? Because when we searched, we saw that this microservices architecture is the good solution for the kind of features that we were trying to solve. But the problem is that when we search for the architecture, we saw the final solution, but we probably miss all the different alternatives, all the different approaches that all these people had to take during their projects. So we took the final picture and we tried to apply the same patterns, the same blueprints to solve our problem. And we miss all the discoveries, all the insights that can appear when we are trying to deploy or to evolve our project. So basically this approach is what I call HDD, hype-driven development, which basically is not a good thing because it's not going to render the same results that we are expecting. And this happens for a reason. And the reason is because that when it's easy to solve a problem, it's easy to solve a puzzle when we have all the information. If we have a bird's eye view of a maze, it's easy to spot the right path to solve the solution. But usually when we start a project, we are left at the entrance of the maze with no information, with no more context on the different problems or the different corners or the different alternatives that we could find along the way. So it's a good thing to remind ourselves when we start a project that we are somehow like Jon Snow. We should try to keep repeating ourselves that we don't know everything, even if we think so. We don't know everything about the context that we are trying to solve, because maybe we will only know everything at the end of the project when we have the final solution. So in this session, what I want to propose you is to have this good way, or this, to have a look to the steps that will help us to arrive to the final solution that could be a monolith, a modular monolith, or a microservices, but trying to approach or to take an approach that is going to evolve over time as we discover all the information that we have. And in this case, my interest is to point you to several techniques or methodologies that will be useful to keep in mind as we evolve in the development of our project. Let's do this with an example. Let's say that that project that we are assigned next Monday to deliver or to start working on is a conference management tool. And this is indeed a very good example, because the moment that we say a conference management tool, we could all have different ideas of what a conference management tool should cover or should have. For example, if we speak with the organizers of the conference, if we speak with the JConf organizers happening this month in Chicago, we will probably identify that they are interested in things like the management tools will allow me to define the dates for a new edition, or to deal with the sponsors, to define which are going to be the sponsor, or to create some channels to speak with them, to organize a call for papers to receive the proposals, to evaluate the proposals, to build the agenda, to define the different tickets that we are going to have for the conference, to deal with the attendees, to have the list of attendees, etc. If we speak with the attendees will be interested in the conference management tool to allow them to check the agenda, to check the information about the speakers and about the different talks that compose the agenda. Also to see how they can buy the tickets or register themselves to participate into the conference. And if we speak with the speakers, probably they will be interested in things like when the call for papers is going to open and when I can submit my proposals. How do I know if my proposal has been accepted or not? How do I know where and when I need to speak? Or how do I interact with the audience in order to reply or to answer any questions that they may have? So these are different ideas, different things that they have in mind for our conference management tool. And here comes the first technique that I want to introduce you. The first technique is called event storming. Event storming basically means that we can sit down. The first step that we are going to take is we need to sit down with the users or third parties or anyone, any system or person that is going to interact with our system. And we need to list all the possible interactions from those systems, persons, users with our system. And with that, what we are going to do is the second step. And for the second step, we are going to introduce something called CQRS, which basically stands for Command Query Responsibility Separation. But basically, this means that we are going to go over the list of the different interactions that we have identified in speaking with the users, and we are going to try to identify two categories in these interactions. Because the first thing that we are going to do to design our system is we are going to think that our system is going to have two main entrances, two main doors to access our system. One door, one entry point is going to be focused on commands, and another is going to be focused on queries. So we need to identify which of those interactions are commands and which are queries. And for that, we are going to look if an interaction means that in order to process that interaction, that request, we will have to change something in the data or in the state of our application. If that happens, we will categorize that request, that interaction as a command. If for processing a command means that we are going to change something, that will probably mean that those changes should be propagated or notified to other parts in our system. We will get back to that in a moment, but for now, let's try to focus that we are we're going to focus on which commands are basically changing the state, changing the data of our system. So, for example, in our example, if we speak with the organizers, we will have commands like define edition or the dates, accept or reject a total proposal, define a Q&A channel in order to allow speakers and organizers to interact, or open the call for papers, assign a new track, things like that. On the side of the speakers, they will probably have commands like submitting a proposal or accepting confirming a proposal that has been accepted, or joining a Q&A channel in order to interact with the audience. For the audience, for the attendees, we will have commands like send a questions in a Q&A channel, or add that talk to my particular agenda because I'm particularly interested in that, or buy a ticket, or rate or give feedback on a talk. These are commands because in order to process any of these requests, we will have to change something in our system. We will have to change data in our system. On the other side, we will have other types of interaction, which basically means that that request is asking for some information to be returned back to the user. So in this case, some examples of queries will be, from the point of view of the organizers, get me the list of all the proposals that we have received, or get the popularity of a particular talk, because maybe that way I'm going to use that information to assign that talk to a different room, which is bigger, has more space for more people, or get the talk rating because I want to have the top 10 rank of talks. From the point of view of the speakers, we could have commands or queries like get me all the questions that I have received during my talk, or get my talk info to know where and when I need to speak, or get me any feedback that I have received. From the point of view of the speakers, could be let me get all the talks, all the agenda for the conference, or let me see all the messages in the QA channel. So with these first two steps, using event storming and applying CQRS and identifying this, categorizing these interactions into two types, in fact, we have done the first exercise to modularize our system. Even if we are not going to create different projects, we don't need that. We can start simple and we can create a project in which we will have an user interface or an API, the set of entry points that will get the rest or will expose the rest endpoints. But then we will have some kind of area in which we are going to implement all the commands. Yes, and on the other side, we are going to have another logical module, which will be for implementing all the queries, for processing all the requests that are going to simply request some information to be returned back. So this means that we don't need to have two different projects, one for commands and one for queries. But we can have different packages, or we can have some kind of convention in order to identify which are the areas that will model commands and queries. So the next step after categorizing this is to model all these parts, these commands and these queries. And for modeling, we are going to use the next technique that I want to introduce to you, which is DDD. DDD stands for domain-driven design, but basically the DDD means that we are going to try to model our system, splitting into different models and trying to find the boundaries between different concepts or different areas in our system. And this is key. This is the most important part of our process, because this is what is going to allow us to identify which are the points in which at some point in the future, we will be able to cut and extract code into different modules. This is what is going to allow us to keep some kind of modularization of our big project. But at the same time, in the first steps, we are not going to have to deal with the complexity of adding modules or thinking in the different modules that we are going to have in our system. Basically, if we are going to speak about modeling, the first thing that I want to show you is this. I want to start with a reflection on what a model is. And for that, I'm going to use this art illustration from a French artist, Magritte. The first time that I saw this image was at a cover book, and I was in the university, I think. And they say that you should never judge a book by its cover, but sometimes the cover is what gets your attention to read the book. And in this case, it was exactly what happened to me, because I saw this in the library. It was a book about modeling and modeling systems. And my attention was attracted by the fact that in French, this means this is not a pipe. And I was seeing a pipe, and I was confused because, of course, that's a pipe. But you are saying that this is not a pipe. Well, it happens to be that this is actually not a pipe. This is the representation of a pipe. This is the model of a pipe. This is a good model if I want to know or to get an idea of which is the shape of a pipe or which is the color of a particular pipe represented here, but it's not very useful. It's not a model very useful if I want to know the size of a pipe, because you will probably see a different size that I'm seeing here in my screen, or it's not very useful. I can't smoke in this pipe. I don't know what a pipe is for, or I can't say which is the weight of this pipe. So this is a model that serves to a purpose, that is not complete, it's not 100% accurate, because a model is just a representation of certain parts of the reality, but not all the parts. Let's see this with another example. These are 4 maps, 1, 2, 3, and 4. And these are 4 maps of the same thing. They are modeling the public transport system in the city of Munich in Germany. And basically, they are modeling the same thing, the subway. But if I ask you which map would you prefer, I don't know what your response will be. But in DDD, a very popular response is, it depends. It depends on what is your purpose, what are your intentions for using this model. For example, if you are someone that is already living in the city of Munich, you will probably prefer the first one, because it's the one that gives the minimum amount of information and yet gives you the information to know which is the path that you should take from going to one station to another one. But for example, if you are someone from another city in Germany and you are traveling to Germany for business, for example, and you need to buy a ticket, you will probably prefer the second one, because the second one is adding information about the area, the geographical area, so that you could know which specific type of ticket you must buy, depending on which is the destination station that you are going to, and which is the original station. If you are a tourist and you are sightseeing or you are interested in visiting the city of Munich, probably the third map, the third model is going to be more useful, because it's adding some kind of information of the monuments or the interesting parts of the cities that you should visit. And if you are already lost in the city, maybe the fourth model is going to be more useful, because it's a Google Map screenshot. And basically, it allows you to know which is the street in which you are and locate the nearest station to go to whenever you want to go. So the key point here is that when we try to model something, we should try to keep the models as simple as possible and keeping only the relevant information that we need for whatever we want to use the model. So in this case, in our system, we will probably, in fact, creating some different models. We are going to model in some way all the commands and how we are going to process those commands. And on the other side, we are going to model in a different way how we are going to organize the information to process the queries. So that having these different types of model will allow us to be more performant and to do things in a better way. So for example, in our command model, we will let's focus on a particular feature, which is the Q&A chat that we are going to implement. And we will have, for example, create chat room command. And we will have, for example, another join room command. And we will have also a send message command, which will allow us to model just the minimum amount of information that we will require in order to process those commands. On the other side, with the projects, with the projections, this is how we are going to model the information for handling the queries. And that means that we are going to actually try to keep the information organized in the way that is closer to how the user is going to request it. For example, if we have a list rooms query, we will try to have some structure with the information prepared so that corresponds to how we need to return that. And for example, if we have another query, which is get the room messages, we will have a list of all the messages organized by date and user that sent it. And there's another thing that we need to model in our system, which are going to be the aggregates. The aggregates basically is in DDD what we call the model that is going to represent the state of our application, not how we process the commands, not how we respond to the queries, but how we model the different bits of information in our system. So basically an aggregate is a set of objects or entities, if you want, and also the relationship and the invariants that should be kept when we are processing a command or when we are doing some changes. So in this case, the aggregate is a key concept because it's going to help us identify the boundaries of all the entities and maybe somehow the transactions, because we are going to keep all these invariants in mind when we are trying to define the aggregates. But let's keep in mind that the aggregates are just part of the domain. We don't need to model the entire system in one aggregate. We are going to model these aggregates just by taking a look at how we are processing these commands. Let's see that with an example. Let's say that we have in our chat room, we will define the aggregate of the chat room, and this chat room will keep, as a model, we will keep the minimum amount of information that is interesting to deal and to represent all the information about the Q&A channels that we are going to model in our tool. For example, in this case, we will model that we will have a chat room with a name and a description and a list of members. And that list of members will indeed be some users. But keep in mind that these users, in this case, for the sake of the chat room, will only be modeled by an ID and a name or a screen name. Probably a user in another part of our system will be modeled in a different way, will be more complex. But in this case, we are modeling the user with the minimum amount of information that we need in order to represent the user relationship with the chat room. And also, we will probably define some invariants, like, for example, every chat room should have at least one admin, or and a user can only join a chat room once. There's no point in a user being twice in the same chat room. So these are kind of the invariants that we need to check whenever we are going to process a command. So in this case, we have already seen that we have these two kinds of logical models. The command on one side, the query part on another side. And we have different models because we will be modeling the command model and the projections for the query model. And we will also have the aggregates, the different aggregates to model how we represent the state of our system. But if we have seen that the commands are going to change the state of our system, that means that we will probably need to update the projections accordingly whenever we change something. And how do we do that synchronization? How do we do that? And for that, we are going to introduce yet another tool or yet another concept, which are the events. The events basically is the tool that we are going to use to coordinate these different models from the command model, from the aggregates, and from the projection on the query model. If we go back to our microservices architecture and we try to simplify it a little bit, we are going to keep just 3 of these or 4 of these modules, in which one module is going to change something. It's going to represent the command handler that is processing a command and changing something in our data. And the other 3 modules are basically another parts of our system that are interested in updating some parts of the model based on the changes that the first producer module did. But the first thing that we are going to do is we are going to break this dial dependency. And what we are going to do is we are going to make the producer, the module that is creating the changes, is going to create an event, and it's going to publish an event somewhere so that that event will be delivered or will be received by the different modules that are interested in reacting to those changes, to the changes that the event represents. So basically, what we are saying is that we are going to use events to synchronize the different models in our system. And another technique that is useful in this point of our project development is event modeling. If we said before that event storming is a technique that allows us to identify all the interactions, all the external interactions with our system, event modeling is a technique that allows us to identify the different events that are interesting for synchronizing the different modules that we have in our system, for synchronizing the different models that we have in our system. But in this case, at this point of this talk, I want to explain 2 concepts that are sometimes used ambiguously, sometimes are used as if they were the same thing, or if they were meaning the same thing, but they are not. So this is one of the key bits of information that I want to share with you in this session. If you are going to just take only one thing from this session, please let this differentiation, this difference, be the one that you remember. Because the rest of it, you will probably have more information, or you will be able to find more information in on internet about that. But this is very important because in internet, there are a lot of times in which event streaming and event sourcing are used as if they were the same thing, or they are using ambiguously and they are not. So this is a key thing to keep in mind. Let's start with event streaming. In event streaming, what we do is we usually have a producer that is going to apply some changes in their repository, in the data, in the state of the application, and is going to put an event on a message broker, on a middleware, in order to notify other components in our system. That middleware will probably store all the different events that have happened before in our system, so that whenever we have another consumer, another module that is interested in those events, that module will connect to the message broker and will receive all the events that are produced on the middleware. So the consumer will start processing all these events and will react and will update their models accordingly. But with event sourcing, we are going to do a different kind of thing. What we are going to do, the approach of event sourcing is basically, we are not going to rely on the producer side, on the producer module. We are not going to rely on the state that we have stored internally. We are going to get rid of that repository, and we are going to trust also the set of events that we have sent before. That way, if we, for example, start another instance of this consumer because we need to support more workload, that consumer will not need to connect, or we don't need to synchronize different databases, because the new consumer, the new producer, is actually another consumer for our message broker. So the producer is going to be able to retrieve the events, or in another case, they will be able to retrieve the events that affect a particular aggregate or a particular entity in order to reconstruct the state of certain parts of our system. So with event sourcing, what we are doing is we are putting the source of truth on the events, not on an internal repository. And we will require that our middleware, our message broker, is not only a message broker, but an event store, which means that we are able to retrieve the events in a particular event, in a particular way. So event sourcing seems to be a little bit more complex because we cannot rely on this internal repository that the producer had. But why should we bother to use event sourcing? Well, the thing is that when we use event streaming, when we store and when we rely on the final state of our entity, we have all the information, but we have the information in a particular moment in time of which is the state of our application. And we don't know anything about what happened before. If we rely on event sourcing, what we will have is the set of events that affected on a particular entity. So in this case, we could get all the events one by one in the same order that happened, and we will be able to apply all the state changes again to reconstruct the idea. For example, we could have first that the proposal draft was sent, and then we will update the status, and then we will receive a proposal update in which we have the author, and then we will have a proposal submit, which will make us change the status to submit, and then we will have a proposal accept, so we will update the state accordingly, and then we will see that the speaker was changed, and then we will update the speaker, and finally we will update that the status of our proposal was withdrawn. But using event sourcing, we have all the information of what happened. And why is this good? Well, this is good for a good bunch of reasons. For example, it will allow us to justify why the state of our application is as it is in a particular moment, because we will be able to track down to all the previous events that we received that were generated in the system. This is good for auditing, for example, or for to comply with some quality metrics. It's also good to for use to with data mining, because we have all the information that previously happened, and we could also use this historic data to apply for new components that are developed in the future with new features. So a new feature will benefit from all the past events, because whenever we are going to start that a new module with that new feature, we will be able to provide all the things that happened in the past. There are also some technical reasons that will allow us, for example, to debug the systems in a better way, or to find why some state at some moment is corrupt or seems to be corrupt. Maybe we could identify which is the order in which the events were received or applied. So event sourcing is a little bit more complex, but is in the end much better for our systems. And then if we have reached this point, we will be able to have, sorry, because I had, so in this case, we will have a monolith that is modular, because we have different areas, different places in our system, different modules and models that are identified. So let's say that at some point we will decide that one of these systems has been really complex, and we need to extract that to a different project that will be dealt with a different system. So hold on. So in this case, we could be able to extract the information into a different project that could be, for example, dealt with another team. Or it may happen that we identify that some part of our system are supporting a very high workload, and then we decide to extract that part of the code and create and deploy several different instances in order to be able to support more workload. For this to happen, well, we are really in this moment, if we have been using event sourcing, DDD, and CQRS, we will be more or less ready to do that. But there's something that we also need to keep in mind, is that while we have been implementing all these modules, and while we have been using commands and queries and events to propagate and to synchronize models, we need to keep in mind something that is called location transparency, which means that all these components should not ever have any kind of information or assumptions about where other systems, where other components are deployed, nor even how many components are depending on the events that I'm sending. So it's important to find a very good abstraction layer that will help us to deliver those events, commands, and queries. How do we keep this going? In order to recap a little bit, the first thing that we need to keep in mind is we need to try to keep our models independent, and this is done basically by using DDD and defining the different aggregates, the different models, and trying to synchronize all these models based on events. So all these, where an aggregate defines a boundary, we will probably need to use events to synchronize different models. At some point, we may find that these models evolve and they are more complex. So in DDD, there are also some patterns that allow us to split those models into simple one, trying to keep in mind also the invariants and the boundaries, defining smaller boundaries for those. So this is basically keeping the models independent. This is something that we can achieve by using CQRS and DDD in a good way. And then the second thing that we need to keep in mind is that we need to use event sourcing to synchronize different modules. And for that, it's not only important to have a message bus as a way to abstract the way that we are going to deliver the messages from one component to another, but it's also a good thing to keep in mind that that middleware should be an event store. And that means that if we want to really use the events as a single source of truth for our systems, we need to rely on a middleware that is going to be able to retrieve information on specific events that are affecting a certain aggregate by its ID, for example. Okay, let's try to put this all together into code. And for that, I'm going to use Axon Framework. Axon Framework is an open source framework that we have developed at Axonic. Axon Framework is basically open source and is a framework that integrates very well with Spring Boot. But you can also use that with plain Java applications. So it's also useful if you are not using Spring Boot. And Axon Framework basically tries to enforce is some kind of opinionated way of doing CQRS and DDD. It's going to help you to build applications following these practices. So let's see, for example, for the command model, I'm using a Kotlin data class here, in which I'm modeling just the minimum amount of information necessary for creating, for processing these commands, in which I'm having the room ID and I'm having also the name. The only thing that is specific to Axon Framework here is that I'm specifying that the room ID is the target aggregate identifier, which means that they will, the framework will will get the right aggregate and will, if needed, will reconstruct the aggregate by asking the middleware to give me all the events that affect that same ID. We also have the join room command, which is also a data class with the minimum amount of information required to process these commands, the post message command or the leave room command. That's the command model. The other thing that we need to implement or to model is the event model. The event model is basically the events that we are going to use to synchronize the different models. In this case, there's a one-to-one relationship between the commands that we are applying and the events that we are notifying with changes, the room created event, the participant joined room event, the message post event, again, with all the minimum required information that is necessary to propagate those changes to other systems, to other modules. And finally, we are going to model the aggregate. The aggregate is how we model the state of the application. In this case, we are going to identify that this is an aggregate, a class chat room, and this aggregate is basically going to have an ID, which is the aggregate identifier, and a list of participants, as we saw in our previous slides. So next, we are going to define how we are going to handle a command. And for that, we are going to use the annotation of a command handler that we are going to put on a method. And in that method, we will need to specify as an argument, which is the command that will be used to link this method as a command handler. In this case, as the method is a constructor, that means that whenever we receive a create room command in our system, a new instance of a chat room, a new instance of the aggregate will be created automatically. So for the implementation of the method, we will basically create an event to notify the change that we have just created, which means that we have created a new chat room. And we are going to use the method apply. Apply is basically going to find the middleware, is the abstraction that allows us to send that notification on the middleware that is going to deliver as an event store and also a message broker. In a similar way, we will have another command handler for the join room command, in which, in this case, we will be when the framework is going to receive a join run command, is going to load the aggregate from the event store based on the aggregate ID, and it's going to invoke the join run command in this instance. Again, what we are going to do in this case is we are going to notify this new event that the participant joined this room. But let's pay attention, because we haven't changed the state in our aggregate on the command handler, because this is where the event sourcing part of our application chimes in. In order to apply the changes, we need to try to keep in mind that our aggregate is going to also receive the events that we are generating. So in this case, we need to add another event sourcing handler that will react to all these changes that we have identified in our system. That means that whenever we create a new instance of this module and we raise that module we deploy a new instance of this module, this module will connect to the message broker and will invoke all the event sourcing handlers for the events that we need and we require. So in this case, the state changes should be always applied on the event sourcing handler on our aggregate. So the command handler is going to notify the changes, and the event sourcing handler is going to apply the changes. That way, we are going to be using event sourcing. Again, the command handler is also responsible for validate any kind of thing that we have to validate on the commands. We cannot validate the events because the events are basically a representation of something that has already happened. We can ignore that. We need to process the events, but we can validate, we can react on the commands that we are receiving, because it's a different nature of concept that we are dealing with here. On the other side, on the side of the projections, we will also have, for the queries, we will have a model, which is a projection. That's the name that DDD gives to our systems, to our query models. And in this case, we are going to define some event handlers that will react, will be invoked based on these same events that we have sent or triggered from the command handler. And the way that the projection is going to react is going to basically update some kind of internal mechanism, some kind of internal repository in order to keep a database or keep a model updated with the data in the way that later on the request will be returned to the user that requested it. So finally, the last thing that we need to do is define the query handlers on the projection, in which we are going to define that certain queries from the query model will be invoked will invoke this method. And in this case, we are just going to simply retrieve the information that we have updated, and we are going to return back to the user. So basically, that's it. That's finally more or less the process in a way. In summary, let's try to avoid the HDD, the hype-driven development, and let's try to pay attention to the techniques that will allow us to discover the different modules and evolve the architecture of our system in a better way. And for this, CQRS, DDD, and event sourcing are really good techniques. So I would like to finish this session by sharing with you a couple of bits of information if you are interested in digging a little bit more. There's a very good talk by a colleague of mine. He delivered this talk at the DevOps UK and another conference, but I don't remember the conference right now. But he also delivered this talk about this demystifying event-related software concepts and methodologies in the Bulgarian Java user group last week, I think, and they have already published that recording. The talk is in English, so you can follow that and try to identify a little bit more of all these event-related concepts in software industry. And finally, I would like to finish by providing you some page in which we have compiled a lot of resources, because I know that in this session I have delivered a lot of information, and maybe at some point you will probably prefer to go back over the details and try to experiment with these kind of concepts and how they are related. So for that, of course, we have compiled the slides, and we also have a couple of repositories with some code samples and a tutorial. That tutorial has different commits with the different steps that you need to go through in order to build something that could be modular. And at some point, you could experiment to split those modules into different projects. We also have an Axon Academy with a couple of free courses on DDD, CQRS, and Event-Sourcing. Some more courses are coming up soon, so stay tuned. Right now, all the courses that are there are free, so you are more than welcome to join us. We have also some information about this Axon Framework project, which is free and open source to use. Axon Framework has different components to connect to different middlewares, but we also have another one, Axon Server, which has a standard edition which is free to use, and an enterprise edition for more advanced users. Also some information on event modeling, and a recommendation to, if you want to dig a little bit into DDD, there's a good book that I will refer to, which is the Domain-Driven Design Blue Book. So you have all this information in that landing page. You can scan the QR code, and I will be more than happy to answer any question that you may have, or if you are watching this recording later on, or if you have some questions later on, don't hesitate to reach out to me on Twitter or in any way to try to ask your questions. And
I had a question.
Please ask your question. Yeah, anybody?
Okay. Would this domain-driven design help with an existing program? I mean, we have a monolith, and we've been asked to. It's a desktop simulation in Java, and we've been asked, we're moving it to the web, of course, and they like the buzzword microservices, and so it's not exactly easy to split up a discrete event simulation using, an event bus like this is doing, because there's way too much information being passed back and forth. So,
well, in this case, if you need to try to split a monolith that is already a big one, I would say that first of all, it's a matter of patience, and it's very important to depending on how big your project is and how complex it is. I will first try to find if there is some points, if there is some kind of logical modularity in there. If you can spot some places in which you can cut and extract some small bits of your project, and try to see how you are going to synchronize that. And maybe it's at that point you need to refactor that little module, first module, and then try to start adding some concepts or remodeling some concepts from DDD. I will say with you, I was like 3 years ago, I was delivering a Java specialist course on concurrency, advanced concurrency, at a company here in Spain, and they told me that they were moving their whole platform into microservices. And at some point I was interested because I was working for another company that we were first trying to redesign our system to become a modular monolith, and then when we have this modular monolith, try to decide whether we will split that into different modules. So I was interested in how they were doing, this other company were doing their thing. And they told me that they were moving to Scala because on top of the microservices buzzword, there was even a bigger buzzword, which was Scala. And they were doing both refactors at the same time. They were telling me that they had been designing the new infrastructure and the new modularization or kind of trying to extract the different modules for, if I remember correctly, 2.5 years. Because they were taking small steps, trying to every time. Of course, they couldn't stop all their developments and start redesigning the whole thing. So they started to do small bits, trying to fit those. Whenever they had a new feature to deploy, they will try to find the different concepts that were affected by that new feature and try to model that into a new module. And it took them 2.5 years. And they were telling me that at that point, they had identified the different points in which they could split into different modules. So they have somehow the infrastructure of where to place the different modules. So we're expecting for another 2 years to complete that process. So I would say that if you are dealing with a very big project, which is very entangled and it's very complex, just try to manage the expectations that this is going to be a hard work.
I think we do have that. But what I was intrigued when the title of your talk was moving to microservices if necessary. So, I mean, I like that idea. So you're saying that modularizing within your monolith.
Yeah, exactly. So the idea,
a better way to start.
Yeah, the whole idea of the session is just by applying these techniques of DDD and CQRS, you will, but don't try to think, if you are going to start a new project, don't try to start thinking in which are the different number of projects or modules that you are going to set up. No, just start with a monolith and try to apply these techniques. And by using DDD, you will be having one single project, but you will have identified the points that you can use to cut the code into different modules, only if you need. Because keep in mind that by extracting parts of your code into a different module will add some layer of complexity, because you will need to deal with different deployment rates or deployment mechanisms or teams or whatever. So the fact that you are going to extract that into a microservices should be worth the effort with the extra complexity that comes from that. But the point of my session is, if you try to use DDD and QCRS, you will be prepared. You will start with a monolith, and that monolith will be modular. And that modularity, it's a good thing, even if you are using just a monolith, because it will allow you to evolve whenever you need, but only if you need.
Great, thank you.
You're welcome.
Quick question about the design principles. I'm not sure if you mentioned, correct me if I'm wrong, but those techniques, to me, they're kind of lower level than a higher principle, which is separation of concerns.
Yeah.
Right.
Well,
so before you, let me just finish. Right. So if you have an application, right, before even going into thinking, oh, what kind of technique, DDD, etc., I think one of the first questions, at least one of the questions I would ask myself is, what are the concerns related to my application? So I'm trying to extrapolate your chat application to another, maybe simpler. For example, you are going to develop a blog application, right? So one part of the blog would be a blog itself, which I would called client, right? That would just show the blog, recent, etc., blah, 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 give you a search functionality. And another part for the blog would be the administration part, right? You need to administer this, right? By maybe creating a blog post, right? By maybe managing users, etc., right? So at this point, you have two separate concerns, blog itself and its administration part, the classic, right? Usually most applications have that, right? So it looks like, well, starting with the monolith, you could do it, right? Put it everything in one bag, right? But I would ask myself, admin has nothing to do with the blog client. That would be only in the read mode, right? Just give me the post. That's it, right? I won't be inserting, updating, deleting, right? That would be the part for the admin, right? So again, make it quick. Separation of concern would give you this answer. At least you would have two applications as far as I'm concerned. The blog client, I would call it, the blog admin, and maybe some common that you can store some domain objects that would be reusable by both, by client and the admin, right? Because I think they would share the database, right? The blogs and the admin would have the same database, right? So they would share some domain objects. So just, again, stress separation of concerns. I think it's a very important principle to follow to begin with.
Yeah, of course, I agree. And it's the whole point here is that well, DD is a very stance technique. And it's basically the whole point is, as you said, let's try to think beforehand how we are going to design our systems, and let's try to keep the design principles in mind, but not try to apply the design principles just because some blueprints of how others implemented microservices or whatever final architecture they had, or external architectures or whatever. So the way should be the other one. If we start with the design principles, we will probably follow a path that will allow us to arrive to a certain architecture, but not the other way around.
Hi, my name is Joshua. First of all, I really appreciated your presentation. You pulled together a lot of concepts I've heard about and show how they fit together. And I also really appreciate just this distinction between the design of the system and the technical design choice of monolith versus microservices. That's really helpful. So my question is, how do you handle race conditions? So for example, the command handler is going to be reading projections to determine whether or not to emit these events. And yeah, does that make sense?
Yeah, well, in fact, this is one of the tricky parts. There are, again, as we evolve using these techniques, sometimes you face some situations that are more complex. But for example, the thing about race conditions, it's using event sourcing means that you need to guarantee that the events are going to happen always in the same order. So that means, for example, it's very important which is the middleware that you are using to store the events. And those message brokers that are good in delivering messages, but they cannot guarantee the order of the events, could happen to face that race conditions that you are not going to be able to deal or to manage in a right way. The thing is that that's one of the reasons why it's very important to decide which is the right tool that you are going to use as event store. So that's really one important thing. And once that you have, there's another implication of this, of what you said, is if I'm on a consumer, if I need to check the state of an entity in order to decide whether I'm going to apply or process one command or not, the thing is that I need to probably recreate the structure and get all the information from the event store. But the thing is that the event store will give me all the information, all the events regarding that that aggregate ID at some point. It may happen that at the same time I'm processing and I'm creating some race condition, and I'm adding some state that can conflict in another module. So that's something that comes with consistency. That is something that you have when you have distributed systems. But for example, one key thing here is that depending on the abstraction layer that you are using as Event Store, and for example, in Action Framework, one of the things that we do is if you are using a monolith, the time that this time spent between when you send a notification, an event, and when you receive that notification on the same aggregate at the command handler level is blocking in that case if you are on a monolith. So everything is executed on the same transaction to say it so. If you are configuring the Action Framework to use another middleware, a distributed system, you will have this kind of situation in which you have some problems derived from eventful consistency. But again, for that, it's also very important that you choose the right middleware to deliver the messages.
So let me see if I understand you correctly. So there's some kind of there's some kind of locking, in a sense, at the aggregate level for particular entities.
Not in the aggregate. Well, the thing is that Action Framework controls how all the messages are applied. And when you configure Action Framework and you are running inside the same JVM, Action Framework can, I'm not exactly sure which is the way that they are going to process on the aggregate. But on a monolith, if you have only one instance, you should not have probably that kind of problems, because Action Framework knows that you are inside the same JVM. And for example, when you are going to send a message to the message bus, the message bus is going to directly call on the same thread to the event sourcing handler.
I see. Thank you. That's really helpful. One more quick question. With regard to events, do we separate events by domain as well? And if so, would producing one event in one domain then sort of cascade to events in other domains? And is that something that Action Framework handles as well?
Sorry, if those events cascade in other events?
Well, so if there's so we have in domain-driven design, we have separation of different domains, right? Different bounded contexts. That's what I'm trying to think of, bounded contexts. So would we have do we have like sort of the namespace of events is a global namespace, or do we have events within each bounded context? And if so, how do we manage those events that may have different versions in different bounded contexts?
Well, right now the events are identified in if you are using Action Framework, the events are identified by their full qualified name. So that's somehow some kind of namespace, if you say so. So that could be to identify the different events.
I see. So just conceptually then, events are sort of global. Everybody sees the same events. We don't have events viewed differently by different bounded contexts. Okay. Got it.
Well, finally, it depends. It finally depends on depending on which is the middleware. From the Action Framework point of view, the events are the same for everyone. But depending on the middleware that you are using, Action Framework has several different connectors depending on the middleware that you're using, and how those are serialized and deserialized depends very much on how you implement the connector. But that's implementation detail. If you are using Action Server, that's basically using some kind of serialization. And from the logical point of view, the events are qualified by the fully qualified name.
Got it.
Joshua, you were good with the answers?
Yeah, I'm good. Thank you.
Yeah. And we have one more question here on the chat dialogue from Karthik. Karthik is asking any book or video tutorials to start designing a product from the scratch. Thanks in advance.
Okay. I will say that there are designing a product from scratch using these techniques, you mean? I would say probably there are. I can't think right now of a complete example from scratch. There are several different useful resources, like going through the event modeling and event storming resources that I point there. But I can't think of an example right now in order to do the full design. But I will review it, and I will send you some information about that.
Sure. No problem. Thank you so much. I really appreciate your time, and really it helps. This session is very useful to, especially to understand when we should go to microservices and what is the decision key factor. And one question I have, one more thing, David. So let's say if I'm getting into a project and where they want to start, let's say startup companies, and I have one scenario where I started one startup company and wherein they want to start a product from the scratch using microservices. And being a startup company, they don't have any particular requirement, but by hearing from the hype of microservice world, so they want to build everything from the scratch as a microservices, and they don't have any definition of how to define the boundary for each context of each services, what to sit where. So there was like a lot of struggles over there. I think like as you said, I remember like if we can starting from monolithic, and then if only required, then only we can move to microservices, whichever is looking for any scale up in future. Only those pieces we can get out of it, and then we can use the frameworks like Axion, and then we can get into that. Is that correct? My understanding?
Yeah. Well, in fact, what you told is basically more or less the same history that I started with some friend. They were an startup, and they were starting just by applying some microservices, and they didn't even know which were all the requirements and all the context on the project. So
Correct.
but by adding some complexity, and they face a problem in which they had to redesign the whole system when they understood
Right.
that the modules that they have designed made no sense.
Okay. Will the Axiom have framework helps to only move from monolith to microservice, or even from starting any product from the scratch? Shall we use Axiom framework?
Well, it's the response that I will say it depends.
Okay.
Basically, if you know that at some point in time you will have some good odds of growing your application into something that is really big, probably it makes sense to use Action Framework. But also keep in mind that if you are going to use a CRUD or a really simple management tool, maybe it does not make sense to use Action Framework from the very beginning.
Okay,
Let's
gotcha.
try to think of using DDD. Always we have some kind of complexity whenever we are going to use any framework, but I would say that Action Framework is quite safe to use if you are more or less confident that your application is going to be big. For example, if you are studying to design a system that will be deployed in the clouds, or it will be dealing with a very complex system, somehow it makes sense to pay attention to how
Okay,
you.
gotcha. Yep. Thank you, David. Yeah, I really appreciate if you can share some link or any reference or any kind of tutorials that we can go through to start from scratch. So as a technical architect, what type of design patterns we have to think, and how to modularize each component when we build a product. So I mean that will help everyone. So Really appreciate if you have that link.
We have a couple of initiatives, and I myself wanted to try to do some samples, some more complete tutorials on how to build a system. On the Axon Academy, if you go there, you will have several starting courses that are very interesting. For a more complete resources, you can also join our discourse platform, in which we usually will be sharing some more resources and more examples on how to.
Gotcha. Yeah, sure. Thank you so much, David and everyone. Yeah.
Welcome.